open this computer and off we go. All right, so it's week 3, Tuesday, half the assignment's out. At least you've got the database. Yes, good afternoon, peeps. Don't know what peeps means. No, I do. Don't worry. All right, so what I want to have a look at today, finish off the mapping from ER. There's a couple of constructs that I hadn't talked about, then say a little bit about assignment 1, then talk about database updating, and then get on to, if we have time, SQL queries. And don't forget, Thursday, I'll be starting at 9:15 instead of 10. So I'll get an extra 45 minutes at least. So hopefully that will allow us to get through a little bit more in these, more examples. That's what we need. All right. Okay, so one thing that we hadn't talked about, true engineers. Yeah, starting at 9 in the morning. Maybe 9:15 is too late. Maybe I could start at 8:30. Who knows? All right, lucky for you, I've got to get up and prepare myself for the lecture, brush my hair, things like that. Put on my makeup. Indeed. All right, multi-valued attributes. So we hadn't discussed how to map them from an ER diagram where they're relatively straightforward. Oops, stop floating around you. To SQL. So the basic method is make a new table where each entry in the table represents one of the values that you would have had in the multi-valued attribute. And of course, you've got to know which entity it's linked to. So you have a foreign key in SQL terms. The advantage of doing things this way, so most of the time we talk about multi-valued attributes simply as single atomic values. We talk about cuisine and we've got Japanese, Korean, Chinese, blah, blah, blah. But if we want these things to be associated with other values, for example, if we're talking about cuisines, we might talk about how spicy the cuisine is. So in the tuple, in the new table, we could also have additional attributes. Tuple, I said, transcription, not tunnel. Oh, God, I didn't even get it right then. This transcription is bizarre. All right, now you might say, all right, we've got an attribute and it's got multiple values. Surely we could just do something like write all the values and separate them by commas and stick them in a string. Well, yes, you could do things that way. But that has disadvantages when you come to do querying. It's a little bit harder to work out. Yes, sure, you can do pattern matching to work out whether someone likes blue, but that is slower than doing a join on the attribute table, if you want to call it that, and the entity table. And it turns out that Postgres also has a non-standard construct for sticking multiple values in a single attribute, and that's the array. So you can have an array of values as well. Now, of course, all of this stuff violates the relational model, which assumes every attribute has a single atomic value. All right, so here's an example of, if you wanted to use comma-separated string and you had a person entity who had their name and their favorite colors, then you give the name and you give all the colors in a string. Okay, that's not the way we want to do it. This is how we want to do it. Oh, no. Well, this is an example. I've got to show you how we want to do it. All right, so here's the example: person, their name, and the cuisines they like to eat. All right, well, let me see. I want to do this on, hey, what? Oh yes. Oops, wrong. EXDB. This is an alias that I use to SSH to d.cse.unsw.edu.au. I've got to try and keep all this stuff in. So that's right. Okay, so I've already got a couple of dump files there. Let's see, mva1.sql. So we've got a multi-valued attribute. So we're going to have a table for people. Remember that I like to give all my tables plural names. And in this context, name is text and it's the primary key. One thing that might slightly disturb you looking at this is that the word name is highlighted in green. When like, nah, SQL standard is too old. Yeah, well, they have got different features. As in Postgres arrays, for example. Right, so here I'm being lazy and I'm doing the primary key on the line where of defining the attribute. And we might have other attributes, although that diagram didn't have any. And that's it, right? So that's what we need for the people table. We don't try and stick into it. What did I call that thing? Liked cuisines. That's a very long attribute name, isn't it? All right, how about just call it likes? And if we did what I had in the previous slide, we could simply put a text value there, but we're not going to do it that way. We're going to do it the good old-fashioned, according to Jimmy, way of implementing multi-valued attributes. Like cuisines that people like. All right. So we need to know the name of the cuisine, which I'll boringly call name again. And that's a text field, and it's not a primary key. Why isn't it? It's a primary key. Non-unique. Yeah, all right, to some extent. If I made it a primary key, then only that it could only be one tuple for each cuisine. So in theory, only one person could like Korean because it's composite primary. PKL, what's PKL? No, there's no composite primary key. See, in fact, the name isn't involved in the primary key at all. It's really just a value. But what is involved in this is a foreign key. Once again, I'm going to take the lazy way. References, people, name. So each tuple here has a reference to a person and the name of the cuisine that they like. So there can be multiple entries for each person. We're certainly not making that unique. It's just a foreign key. So I can have John, or reference to John likes Korean, reference to John likes Lebanese, reference to John likes da, da, da. So there could be multiple entries for a given person. Calling it, let's call it cuisine. That's probably better. Just giving everything. One of my neighbors is. No, there's not. Bad luck. All right, so that's the standard implementation of multi-valued attributes. Rather than having an entry in the main table, the table for the entity person, we have a separate table which has references into this table. And basically what that does, it allows us to have multiple cuisines that each person can like. And of course, that's the whole point. We're talking multi-valued attributes. What are the three dots? Oh, all the other attributes for person. So, you know, obviously we're not, a person isn't just going to have a name. They'll probably have other stuff as well. Well, it kind of is standard, but not, it's not the standard mapping to do it that way. The foreign key will need to be not null, right? Yes, correct. Because then we could have a cuisine that was just floating loose. Otherwise, we could be wasting space. No. There would be no point having attributes for the null person. I get, you know, right, if you want to say that's wasting space. Yes, that's true. All right. So that's the standard mapping for a multi-valued attribute. So anything like this becomes a table in its own right, and effectively we have a foreign key referring to the original table. All right. And the other thing that I didn't talk about, which is a lot more complicated than that, is class hierarchies. And it turns out there are three possible ways, well, and maybe more, who knows, but three standard possible ways for mapping class hierarchies. So, what my favorite cuisine would be Korean. It has to be because I'm married to a Korean, and they hit me if I didn't say Korean. Korean fried chicken and beer. Damn, that's nice. Yes. All right. So mapping class hierarchies, three strategies for mapping class hierarchies. One strategy is, and I'll just jump, yeah, Bulgogi's nice. All right. So here's class hierarchy. So we've got the parent class or the superclass, and we've got the three subclasses of this class. Yeah. Yeah, all right. So how do we map these? One kind of obvious way that you could think to do it, well, we'll just have a table for each of these entities. And that's fair enough. Obviously, there's going to have to be a connection from, a connection from each of these up to the parent entry for a student. So that's the ER mapping. There's another mapping called OO, which I never used and always thought was a bit silly, but it does have some advantages. Or is that what the D stands for? Oh, disjoint. I'll get back to that in a moment. So in the OO mapping, you still have one table per entity, but rather than leaving all of the attributes up here, you copy them all down into each of the relevant tables. You might say, what a stupid idea. You can just have a foreign key that links to student and keep all that stuff in one place. And that's true. The only advantage of the OO mapping, as far as I can tell, is that it avoids the need for joins in some contexts. And we'll talk about joins later. So it can have some efficiency benefits. An obvious downside is that this is overlapping. So there's no D here. Where did you get the D from? I don't know. What was I saying? Oh, damn. Should stop looking at joins. Can be slow, yes, if you have to do them a lot. So this says they can do masters, undergrad. Yes, correct. So you might say, well, that's not very realistic, but hey, this is what we decided to model. So maybe there's a university in a universe far, far away that allows that. Right, in any case, the OO mapping basically have a table for each entity type, but the child entities inherit all the attributes from the parent. What's the name of these slides? It's you can access them. Oh, maybe I did. I'm not sure. Yeah, I think I did. Let me see. Oh. Always forget to. Wrong one. They say, oops, that's last year. That's this year. Almost the same, different color. Online sessions, there should be an entry slides. So I think this is where I've been doing them. So blah, blah, blah. Yeah, right, mapping class hierarchies. The last one's come on. Good on you. That's fine. Right. And the single table mapping is where you basically no longer have multiple tables. You just have a single table which contains all of the attributes for all of the entities in the hierarchy. And to do that, you need some kind of mechanism to distinguish what kind of subclass is involved, if any. All right, so each of these strategies has different advantages and disadvantages. I like ER because it just seems more natural, although it does use more space. In some contexts, doing a single table mapping is actually useful. It saves space. Space, it's cheap. No, it's not. All right, tell me that when you fill up your disk or your SSD. And a major advantage of this is it can implement disjoint, because the other strategies have problems implementing total participation. You can't if you have multiple tables. And implementing overlapping and disjoint constraints is a bit questionable sometimes as well. So let's have a look. Here's a class hierarchy. Let's do the mapping 3 different ways. Oops. And that's an O for overlapping. All right, so obviously we're going to have a table for students. Oh, I need to move this out of the way a bit. I can, yeah, it doesn't quite work, does it? No, it doesn't. I can move it further. Oh yeah, that might work well enough. Create, well, not quite. All right, so a student has what? Primary key is a SID, whatever that is. Let's assume it's an integer, and it's going to be the primary key. Once again, I'm being lazy, not putting that down the bottom of the create table statement. Person's got a name. Let's keep it simple and make it text. And let's assume they have to have a name. And finally, an address. I mean, if it was UNSW, they'd insist that they had to know the address. But let's say we're not at UNSW because we're allowing people to do undergrad, PhD, and masters all at the same time. So undergrad is, right, that'll do. I could call it undergrad students or something. But one of the critical things is that an undergrad student has to be associated with one tuple in the parent class. So it's going to be a foreign key that references students. SID. Right, so that's the linkage. So we know that this person down here references this student up here, and if we know this student entry, we can get the SID name and address. The only other thing that an undergrad student has is that they're studying a degree. Right, so let's just make it text. And SID is also a primary key for this table. Left out the comma there. Undergrads. All right, so that's set up. That part of the hierarchy. Let's check by masters students are also students, so they have to have a reference to which student they are. They don't have any additional information, which you might say, that's a bit strange. All right, let's see. Comments here. Yeah, I won't be bothering with serial here. All it does is create confusion because people will say, how come it's an integer in the other one? See, the classic mistake that people will make is if I did serial, they'd say, let's make this serial, which means it's going to generate a unique SID each time. And then when I come down here, they'll say, oh, it's a reference, so it's got to be the same type. And they'll do that, which is wrong. Yes. That would be okay, but you have to know that serial is really an integer that has an auto-generated value. So let's assume I'm generating, yes, it has to be the same type. The foreign key has to be the same type as the primary key it's referring to. Whoa, stop asking questions. Does the order of writing not null and references matter? Might not. If you're worried, you can always put the foreign keys at the end of the table definition. Is that how our ZIDs are generated? No, I don't think so. Yeah, all right. So what have we got? And we've got a PhD student has thesis. All right, maybe that's just the title, or being an arbitrary size text, it might be the whole thesis. So So that would be the ER mapping for that class hierarchy. Mapping, ER mapping. Okay. So that becomes that. Now, let's see what else we got. Overlapping, no problem. A particular seed could appear in all of these tables. Oh, yeah, ooh, yes, good point. Oops. That's what you get for copy and paste, isn't it? PhDs. All right. Yeah, so overlapping, it's okay. This could refer to a particular student. This could refer to the same student. This could refer to the same student. Total participation. Interesting. Yeah. Total participation. Can we force a student to exist in at least one of undergrads, masters, and PhDs simply by writing constraints here? And of course, the reason I'm answering the question is because it's no. So under this mapping, you can't actually implement total participation. Now, of course, you could have something at the application level that forces every time you enter a student, you have to tell a system whether they're an undergrad, master's, or PhD, and then it would create an appropriate tuple there. So you'd always have that. But you can't specify that just using standard constraints. And it's kind of like the information flow is in the wrong direction. So the information flow goes upwards from each of these. So the thing up here doesn't really know what's going on down at this level. Yeah, all right, keep going. What, some count undergrads. If you do it through a constraint in the application, yeah. Yes, for sure. But you can argue it's a weakness of the ER mapping. So the question was, if you do it through a constraint in the application instead of through the database, wouldn't that be a weakness? Yes. You could do it if you wanted to make sure that it was done in the database. You could write a PLPG-SQL function and always have to insert new students using that function, not just using arbitrary insert statements. And that would kind of push it down to the database. It sure is better to constrain in the database, but as I said, you can't under this mapping. All right, so let's have a look at, I won't bother with the OO mapping because I don't use it and I think it's silly. I'm sure someone will pop up and defend it. Enforces data cleanliness, definitely. And that's really the whole point of constraints. Create table. So we have a single students table. Oops. And why didn't I just copy from up here? I am a goose. All right. So Sid, they got a name, they got an address. They may also be doing a degree. And they may also be writing a thesis. And that is perfectly allowed because it's overlapping. Too bad you can't really ban bad words in database text. Yeah. All right, so that could be a way to implement it in a single table mapping. Very simple. We don't have to write as much SQL. That's one thing. And I guess how would you recognize that a student is an undergrad or a master's or a PhD? Well, all right. How would you recognize that? Notice that I've deliberately left these not null. So if both of these were empty, then you could assume that the student was a master's student. If they had a thesis, if that was not null, so if it actually had a value, then you could assume they were at least a PhD student. If they had a degree, you could also assume that they were an undergrad. So the only, oh, yeah, that's an interesting one. How do you know they're a master's student if they have both a degree and a thesis? Well, we could add another. And this will probably generate a syntax error if I try to load this, because you can see it's brown, which means reserved word, which means that's not a good place to put it. Let's call it S type, so it's the student type. Actually, that's not really going to help a lot either. What if PhD student? Yeah, well, in that case, they would be a PhD student and an undergrad student simultaneously, which we said was allowed because we're in a universe, we're in a parallel universe where student can be all of these all at once. Interesting for the masters. Maybe we just, all right, so we're not going to add a type. Maybe we can just add a flag and use another data type, Boolean, which exists in Postgres. Hey, that's what I just put. Before looking at your suggestion, yeah, so you could do that. So then you'd easily be able to recognize. Are they an undergrad? Yes, because the degree text is not empty or null. Are they a master's? Yes, because that says true. And are they a PhD student? Yes, because that says thesis. They have a thesis. All right. Let's go to another. Single table mapping is a demonstration of the OO style. No, the OO style would still have 4 tables. All right, if you want to know what it looks like, it's probably not too do. I'll add it at the bottom. Where'd that come from? What'd that say? I don't know. Oh, goodness. Oops. All right. All right, so I have a table for students, and then rather than having a foreign key, just repeat all of those. Repeat all of those fields. Oh, and look, and I'd already said primary key, so don't need to do that. It's not going to be there. It would have been smarter to take it from the other one, wouldn't it? So that's what a master's student would look like. And and they'd have a thesis rather. There it was. All right, so that's the OO mapping. So you can see that we've got these SID name and address repeated in each of the tables. In what situation would you take the trade-off of using more space by repeating fields rather than foreign keys? Foreign keys require joins. If we frequently wanted to work out what's the name of a PhD student, this would be the most efficient way to do it. If you wanted to work out what's the thesis for a PhD student with a particular name, in the ER model, you'd have to go and look up using the name, find the SID, and then go to the table and then go to the entry in the PhD table that had that student ID, and then you could get the thesis. In this case, if you know the name, you can straight away look up here, and then you've got the tuple which has the thesis. On the other hand, this is, do you still need students table? Yes, you do, because you've got to have the parent class, because the parent class may be involved in relationships. So all of these might be involved in their own relationships, like a PhD student might be related to a supervisor. A master's student, I don't know, they don't seem to do much. Takes up more space, and it's also more difficult to organize the entry of a new thing, a new person. So you can add them as a student, and even with this too, you can't enforce the total participation. There's no requirement for a person who's a student here to be entered in any of these tables either. Need to reference students table. No, they're not referencing the students table. I mean, conceptually, it's kind of a reference, but it's not being used as a foreign key. It's a primary key in its own right in this table. Because the other downside of this too is that you could have an undergraduate student who's not registered as a student, which may be a problem if students are, if all types of students are enrolled in courses, right? And you can say, oh, that's not very realistic for a PhD student, but our PhD students do have to take some number of courses. So every student is associated to one or more courses. You can't really do that nicely if all you had was these tables and you didn't have that one. Why isn't SID a foreign key here? It's not a real foreign key. It's just a copy of a primary key from another table, and it functions as a primary key in this table. A foreign key would be defined as a foreign key, and it would say it references the other table. I don't know if that helps. Hopefully it does. Why wouldn't we implement? Yeah, well, we did. I mean, go back up here. There, it's a foreign key. Oh, but you're saying why don't we define it as a foreign key here? Yeah, I suppose we could. Yes, an undergrad student and a master's student who was one in the same student would have the same student ID in this case. Why wouldn't we implement it as a foreign key? Because it's not really a foreign key. It's an attribute in its own right. and it doesn't rely on the existence of a tuple in another table, which is essentially what foreign keys do. But what it does, we're basically trading the ability to add constraints in the last model for performance. Yes, yes. All right, but I would argue 99% of the time we do, 90% of the time we do it like this. Occasionally a single table mapping would be fine as well. A undergrad, B masters, C PhD, would we have A, B, C in the students table? Yes, correct. And A in undergrad, B in masters, C in PhD. That's exactly what we have. All right, I wanted to, with that, sure, it introduces a lot of data redundancy, but as I gave the example before, it helps with some kinds of queries. Here's another one, all subtly different. Rather than having an O here, we've got a D. All right, so how would that change things? For the ER mapping, basically you just can't implement D in this case. So you can't implement total participation and you can't implement disjointedness with standard SQL constraints. So you lose that. Does that matter? Not if you can, at the application level, force students to not be undergrad and masters at the same time. If a student was both an undergrad and a master's, they would exist in both tables as well, right? Yes, that's referring back to the OO mapping, I assume. All right, so this would be the implementation for disjoint. Single table mapping, and you'd have exactly the same problem with the OO mapping as well. But with a single table mapping, you have a little bit of scope, and I was kind of heading towards that before, that you could have a type. That single table mapping, if you introduce, wow, you're ahead of me. That's good. Yes, correct. Would student ID no longer be a primary key? No, it's still a primary key. The type, you can have lots of students who'd have the same type value, and the student ID doesn't determine, well, it does determine the type. Let's see, so using UNSW's notation for the different types of students, you could do that. Now, about the single, if we introduce a type attribute, yes, all right, so that's what we've done. So this does allow us to implement disjointedness, because this field here can only have one value. But you might want to add additional constraints to check that if the student was undergrad, that was false and that was empty, null. There's no need to introduce a type attribute in the overlapping case if you're talking about the ER model. Or are you talking about... I started to add that. Why did I stop it? to some extent. In fact, that would supersede that, right? So you wouldn't need is masters, because that you could determine that from the value of this attribute. So that could be a way of doing it. Or I probably should overlapping subclasses, that's what we'd have. And if they're disjoint subclasses, hopefully this won't be too confusing when you go back and look at this. Name, oh, did I have address? Oh, I do. All right. Not sure where to put S type. Maybe after the fields. And degree as well. No. Well, you infer the degree from the type. So UG is an undergrad degree. I've got degree. I've got degree. The other issue you might have here is you might want to add an additional constraint. And this gets messy. So if S type is equal to UG, oops, G, if we were to introduce, are you appending it to the student ID? Oh, okay. Yeah, that would kind of solve the problem, but it would mean you'd have to have multiple entries for the same student. And SID would no longer be a primary key. It would, the combination of the numeric value plus the type of student would be a primary key. I don't know. Oops, type it right and I think I got that right. It's a little bit approximate, but all right, what we want to say here is if the student type is undergrad, then thesis ought to be null. Otherwise, it's a funny entry because UGs don't have theses. If the student type is PG, which is masters in the UNSW vernacular, then both of these things should be null. And if the student is a research student, then the undergraduate degree should be null. Yeah, all right. So there's a couple of things floating around here. Real disjoint, you can give constraints names. You don't have to, in which case Postgres will invent some wacky name. But if you violate this constraint, then if you've given it a name, then Postgres will print out that name and say, you know, real disjoint constraint violated, or something like that. So that gives you a bit more of a clue than the internal name that you'd get. I think, in fact, in this context, having a constraint like this, you might actually have to give it a name. I don't think, you know, so what you're suggesting is I could chuck that out and just have check there. I'm not sure that that would work. Maybe you could leave out the name here and just say constraint check. Anyway, doesn't matter. No, like, have, whoa. So real disjoint is the name. Yes, okay, to constraint, doing thesis, text constraint, real disjoint, check, PG equals masters, RS equals PhD, yes. I guess you could have them as 3 separate constraints. That's probably okay. And if any of them's violated, then you wouldn't be allowed to insert the tuple. So that's really all this is doing, is checking for valid combinations of attribute values. And if you try to insert a new tuple that has an undergrad and they have a thesis, it would reject the insertion. That's true. Is there a reason we can't add the check directly to the thesis attribute? Yes, because it involves other attributes as well. So it's actually the combination of these two things, which is what we're checking. Yeah. So it's what's technically known as a table constraint. Okay, so anyway, that allows you to implement disjoint, but still, I was going to say it doesn't allow you to implement total participation, but maybe it does. If you insisted that that be not null, then you'd have to specify a type for the student. So maybe this implementation here can completely capture the semantics of that. This would allow an undergrad with no degree. Oh yeah, good point. Thank you. It's getting carried away there. Degree is not null and thesis is null. And similarly down here, degree is null and thesis is not null. All right. So I think that captures it. Yeah, it would. So I just fixed that problem. All right. So in theory, with a single table mapping, you can fully capture the semantics of this ER diagram. And hey, it's 4:58. That strikes me as a good time to have a break so that I can get some water. So I will pause the recording. I'm surprised you didn't put a question mark after water, as if to suggest Jess is off to get a beer or something. All right, pausing recording now. All right, recording resumed. Let me get to these questions. Wow. Hey, stop asking. I've got to scroll back. There were some older ones. This would allow an undergrad. Oh, you're right. I dealt with that one. So for 004 disjoint. Yeah, 00 looks the same. And once again, because they're separate tables, you can't force something to be entered in all the tables that it needs to be entered into. So you could add a student, but not add them as an undergrad. So in which case, you wouldn't get total participation. Yeah. For S-type, so the S-type, does it mean in the ER diagram? Ah, yeah, that's a good point. No, you wouldn't add that into the ER diagram. That's something that would be inferred from the mapping. In a similar way to, multi-valued attributes, you write them as multi-valued attributes, and then in the SQL implementation, they become something different. They become a new table. For real disjoint, I'm still confused. Will it? Oh, yeah, all right. Where are these constraints used? In fact, this applies to all of the constraints, primary keys, not null, and so on. They're all used when you insert new tuples into the database. And basically, if a new tuple doesn't satisfy all of these constraints, like if you put in S type as X, Y or something, then the tuple won't be inserted. So that gives you a guarantee that the stuff that's in your database is correct or valid, or at least that it satisfies all of these constraints that you've set up, which is a very useful property. So, an example of that is if you've got a table that does have a foreign key, in fact, we got that up here. If you try to enter an undergrad with a student ID that doesn't already exist in the students table, it won't let you do it because it fails this particular constraint. The integer value that you're trying to put in this undergrad's tuple does not reference a known SID. Okay. So constraints are used when you insert tuples, and to a lesser extent when you delete them. What happens is, the same for overlap and disjoint. Yes, it is. I guess you could put an S type into the students table, but that certainly would not solve the disjointedness problem, and it wouldn't solve the overlapping problem. So you can put an S type into student, but there's nothing to stop you adding tuples for this particular student into both masters and undergrad. So that would violate the disjoint. For the OO mapping, I don't understand why we didn't make SID in the subclasses of foreign key. Yeah, you could. Yeah, that follow-up is probably close to the truth. How do I get rid of someone who's trying to call me in the middle of a lecture? Oh, no, I didn't want that. Yes, I want to leave. Sorry, can't talk. Red button. I couldn't see the red button. All right. Anyway, they'll probably think I'm rude. Quite right. Yes, poor Satna. Oh well. I'm sure she'll get back to me later. I'm tempted. Just well, I should edit this out. No, I won't even. She'll call back. What was I saying? Can't remember. No, I see now it's all scrolled up here. Because yeah, that's pretty much the reason. I mean, you could if you wanted to. Total participation because they have to be part of either. You, yes, correct. That's why that is not null. So that forces you to say what they are. And then having said what they are, then we can do this check down here. Right, enough on those mappings. What's next? Assignment 1. Oh, good. All right, so my favorite topic, beer, and a database of beer. And I'm going to come up with a whole bunch of tricky, whatever, queries for you to ask on this database. So what's it got? It's got, oh, really? Oh, there is no assignment 3. I don't know, why is that there? No, there's no assignment 3. Huh, interesting. Where is that? Where are you claiming there's an assignment 3? And under in WebCMS under assignments, really? Oh, shit. Yeah, all right, that's assignment 2. I haven't fixed that yet. I can fix it right now. Oh, that's all visible. God damn, that's last term's assignment. Yeah, 20T3. That'll fix you. All right. So now you can't see it. But there won't ever be an assignment 3. It's going to be assignment 2. All right. So this database obviously has beers. Yeah, no, it's not the assignment 2 for 21T3. It's just leftover from last year. Yeah. So beers have to be made by somebody. Ah, oh, damn, that's no, that's all right. Beers have to be made by somebody, so that's a thick line. And as it says somewhere in the spec, and I had the wrong diagram up yesterday, beers can be made by multiple breweries. So 2 breweries can get together and make a beer. Breweries, manufacturing facilities that are located in a particular place. A beer is brewed to a certain style, like it's a lager or it's an IPA or whatever. You're going, what? Marking script, yes, that's right. Word will know the auto marking tests that run a you'll know some of the tests, but there will also be extra hidden tests. Yeah. All right. So a beer is made up of stuff, so it contains ingredients, 3 different types of ingredients, hops, grains, and adjuncts. And you may say, oh, look at that. All the subclasses have the same attribute name. That's true. Can I move this to... Right. Hopefully that solves that problem. Shouldn't the line on the right of brew also be bold? No, where on the shouldn't the line on the right of brood, are you talking about this? That is bold. I guess we can have breweries that haven't brewed a beer. Exactly. Yeah, it's like pub with no beer. Brewery without a beer. Maybe they can brew ginger beers. Yeah, you always have problems with things like this. If I make a total participation and I add a brewery before they make any beers, well, I can't, because it's supposed to be total participation. If I have it like this, then yes, it allows this scenario where some breweries haven't yet brewed any beer. And yeah, maybe they're making seltzers. Could be right. All right. So yeah, beers contain ingredients. We've got a Lamass class hierarchy, which I'll talk about in a minute. And yeah, that's about it. Simple. All right. So what do you do with this? Nothing up my sleeve. Here I've got a dump of the assignment one database. So if we would have a look at a dump, a lot of the time you could argue, yes, quite right. What we see, well, there's a bunch of weird stuff, but we can see that it comes from Postgres. Oh, it's dumped from version 12.5. Interesting. I hope it works on version 13, which is the one on VXDB. And we've got some domains that I've defined. If you have a look at the schema, there's the SQL schema somewhere, you can see that. These, of course, show more or less the internal representation. There's an external representation that looks a little bit different to that. So I think it says an IBU value is a number in the range, an integer, which in the range 0 to 200. And so that's expressed here. So it actually uses the between attribute. Yeah. All right, Matthew's comment is interesting. It's easier to make a total to keep the database clean. The problem with saying that is as soon as you have an end-to-end relationship, you can't actually enforce the total participation. Yeah. All right. So we're creating some types. We're creating more types. Eventually we'll have a table somewhere. Hooray, here. All right. Creating a table called beers. This public thing is it's part of the namespace, basically. So within the database, you have schemas. And if you're not interested in dealing with schemas, then you just end up using the public schema. And so all these things that I've defined, like year value, ABV value, IBU value, were all defined in the public schema. So it puts, the complete qualified name of everything. What else? Oh, yeah, one thing to notice. So in the SQL schema, I think the constraint is actually defined in the attribute on the same lines as you find the attribute, but internally it ends up as a separate constraint. Brewed by... all right, this is interesting. So these two things are actually foreign keys, but it fails to mention the foreign key aspect here. It actually adds all of the constraints at the end. Why do we need public? Every database has to have at least one schema. If you don't mention, there's always a public schema. And if you don't want to take account of schemas in any way. You can just define everything as is, and and they'll be defined in a public schema. So it's sort of a default schema when you don't want to mention schemas at all. I mean, the notion about having schemas is, in theory, you can have multiple different data models implemented in the same physical database, but we don't normally do that. It's just one database, one data model. The SQL, yeah, sure. All right, it doesn't mention their primary keys either because, as I said, it inserts a lot of the constraints afterwards. So it defines all these tables. Obviously, here's a counter example. There's a constraint on a particular attribute, and it defines that as part of the table definition. But I think same up here, it didn't point that out. At least it tells you it's not null, but it doesn't mention that it's a primary key. Someone's gone back to, oh, okay, good. So we can't implement total participation for the beers. They must have a brewery, correct, because it's an end-to-end relationship. If they're associated with one brewery, i.e. if we didn't have collaboration beers, then sure, you could stick a foreign key in the beer table referencing the brewery that actually brewed it, and you can make sure that foreign key was not null, which would implement that. I changed the schema as well, because one minor change, I've changed this total participation constraint to partial, because there are many, many beers for which we don't know the ingredients, because brewers don't want to give away their secret ingredients. KFC beer, what the hell? It's quite possible. In fact, there are some, well, yeah, that too. But the notion of a KFC beer is interesting. I have had beers that breweries have thrown a barbecued chicken in the brew. Couldn't taste the chicken, but interesting. So I don't see why you couldn't make a beer by throwing a bucket of KFC into the mix. Yeah, suggested to someone. There's plenty of local breweries who are likely to try something like that. Batch in Marrickville, for example. Just throw it loyal. Yeah, all right. So this is a database dump produced by PG_dump, and I can use that to build the database from a single file without having to load a schema and then load data, blah, blah, blah. I've probably already got one of these. Oh, look. Two things I noticed from this. Well, one for sure is that I haven't sourced my env file. And the other one is there doesn't seem to be a server running. So yes, thank you, Maria. Won't be source./env. It's actually because I'm not in that directory. But if I give the full name, and then I can do P1, then I'll have a server, and then I can do PSQL-L, and I already have an assignment one database. So let me get rid of it. Gone. I can check that. No S1 database. So I need to make one. What this does, it gives me a database that I can go and look at, but it's got absolutely nothing in it. It's got no tables or relations, and obviously no tuples, because tuples belong in relations. All right. So to put some stuff in the database, I can do PSQL S1, reading from the s1.dump file. That's what -f means. Read the SQL commands from the file name following. And I tend to write the output to a file. I think I called it log in the spec. If you're on you think, oh, what? You must have been in a directory where you didn't have write permission. If that happened to you, check what directory you're in when you do that. Works for me because I'm in one of my directories. All right. This log file's a bit boring, potentially. So it goes blah, 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 create stuff, copy stuff. Oh, that's a bit smaller than I was thinking. Yeah, it's loading up the database using that copy command, so that can load up stuff really fast. And all these alter tables down here is where you're actually adding all of the table constraints like primary key and so on, because you can't check primary key constraints until you've got some data in the table. All right, and the only reason I create the log file is that I want to make sure there were no errors, and that won't help. That might. And so I can look for errors in the log file. If grep returns nothing, it means there are no errors. Given that these log files are pretty small, you could actually just go and look at them. Some of the other log files that I've created have been much larger because I've been doing individual inserts. So that's why I tend to write them to a file. All right, so now we've got this one. We've got our database. It's got tables, beers, breweries. Okay, so once I pluralize all of these names, brewery and location. Oh, yeah. All right. Well, it's not really log and the two. It's really the greater than in front of the log. So it means write to a file called log, write all the standard output from the PSQL to a file called log, and also write any error output to the same file. So yeah, merging standard error with standard out. That's exactly right. So, I mean, that's a way of capturing the error messages in case you end up with hundreds of error messages, which I did a few times while I was building this database. Getting quite dark in my room. It's not really showing up. This camera is pretty smart. What does that do? Huh, makes it a bit brighter. Good. All right. As soon as what? A wild where? I can't see one. That's because we all use the shell. You can't avoid the shell. Don't try and avoid the shell. The shell is extremely powerful. Remember that. Remember that. Shell good. Yes, exactly. Yeah. All right. So we got the database. What can we do with it? Oh, one thing we might be interested in, how much how much stuff is in the database. So I added a little function called dbpop, database population, which runs through the database and counts the number of tuples in each table, and it tells me that. So there are 637 beers brewed by 662. There are 662 entries in the brewed by table. What does that tell you? What? Yeah, maybe I did, but over a period of years, it wasn't. Some beers, yes, all right. So that's exactly what that tells you. Some beers, 637. Some of the beers must appear in multiple brewed by tuples, which means that they're associated with multiple breweries. So they're the collaboration beers that I'm sure I talked about somewhere in the spec. And if I didn't, that's going to be one of the queries. Find all the collaboration beers. All right, 223 breweries. Clearly, each brewery brews, well, 0 or more beers, and obviously some brew a lot of beers. Some ingredients information. All right, once again, so you can see where the link is, contains ingredient. Obviously, there are some ingredients that are used in multiple different beers, and 195 locations. That's interesting. I thought every brewery had a location. Oops. Something went wrong there. Doesn't matter. That can be a source of another query in the assignment. And 142 beer styles. Hopefully, so let's have a look at the styles table. Oh, look, I'm writing SQL. Blah, blah, blah. Hopefully there's no repetitions here. I think I went through and made sure there wouldn't be. All right, hopefully. And you may say, what the hell are all of those? I've never heard of those type of beers before. Correct. When do you suggest we starting on the assignment? You can do part of the assignment by the end of this week once we've done the online sessions, or you can look at all those videos and work it all out yourself. Beers and contains, why there are only 480 contains, because yeah, all right, that was something I was going to say before. I changed this to a thin line in the spec. This is an older version of the schema, because not all beers, we don't know the ingredients for all beers. Is DB pop an original function in Postgres? No, it's one that I wrote. I won't show you now, but it's an example of a PLPG SQL function. Yeah, I agree. Number of breweries should equal the number of locations. That's a bit strange. I'm not going to go back and fix the database now. That is odd. Oh, no, it's not. I know why. Why could this be? Because several breweries might be in a particular location. So the granularity of locations is just down to the town level. So if there were multiple breweries in a town, then you're only going to have one location tuple for all of them. Yeah. So clearly Marrickville is going to have hundreds of breweries. That's right. Oh yeah, may as well have a look at that. What do locations have? Whoops. Oh, what do I do? Yeah. Locations. Right, so a location has an ID. That's something else I should mention. All of the tables that are entity type tables have an integer ID value, rather than trying to use some combination of the attributes as a key. So locations have a country. They all have a country. You can tell that because it says not null. So number of locations less than number of breweries. Yes, if you've got multiple breweries in the same location. Do we need anything? Probably. So first part of the assignment is going to be SQL. You can go and look at all the SQL videos. There's a few of them. And the second part of the assignment is PLPGSQL, which I won't talk about till next week. But you can go and look at the PLPGSQL videos now if you want to get ahead. Was Q9 and Prac 3? Well, I just slipped it in there. It wasn't compulsory and it wasn't assessed. So trigger, yes. We won't be doing triggers in this assignment. We'll be writing functions that extract data and format it in complicated ways that you can't do with a straight SQL query. Whoa. Can if you like. I'm going to, if I haven't got the PLPGSQL videos from last year up yet, they should be. I'm pretty sure they are actually. Hang on. Let's see. Slides and videos. DDD. PLPGSQL. PLPGSQL. Go to YouTube. Yeah. Yep. See, they're all there. Yeah. No, they're 2020. Not. Why do you want 2019? No, it's not. Where's the number of subscribers? It's less than 1,000. So I can't monetize. Yeah, exactly. What do you need? Because offline was so much better. Huh. I don't know. Shut up, John. Oh, yeah, that's right. I could talk over the top of myself talking. Wow. Wow. I don't, yeah, ad revenue. Yeah, well, that's slightly unfortunate. You could always pay for YouTube Premium, like rich lecturers do, and you never have to look at an ad again. Thank goodness. That's so nice. Right, in any case, you can go and look at all these. Could be. You can go and look at all of these videos if you want to get ahead. I mean, that was, someone mentioned this in the forum today. Oh, really tied hair. Yeah, if you're looking at last year's videos and there's hair tied back and I seem to have some kind of sash over my shoulder, that was because at this time last year, I broke my arm and couldn't sort my hair out, had to wear crappy shirts because I couldn't put my t-shirts on. How'd that happen? I don't know. There was no beer involved. No. You don't use your arm inserting tuples, like use your finger to press the button. Seems very sus. What do you mean seems very sus? I tripped over a piece of furniture at home and we have very hard floors. That's all that there was to it. Very annoying. So for a whole lot of term 3 last year, I had to type one-fingered. That was all I could manage. And it made doing online lectures a little bit on the slow side. All right, let's get back to this. The database. Yeah, so there was a couple of questions. If I wanted to know how many breweries there were, how could I do that? I could say, how many tuples are there in the breweries table? And it would say 223. And if I went back and looked at that DB pop output, I would be very happy that it was consistent with that. Will we just add the PL PGS graph function? Yeah. All right. So the deal is I'm giving you a .sql template, and I want you to fit every count one. Where did I use count one? Yes. All right. It's probably going to work, isn't it? Yeah. Yeah, there is a difference. I mean, you achieve the same result, but the difference is it's kind of, the star means tuple, if you like. So it's counting the number of tuples from the breweries table. Here, what you're doing is and you're doing that by scanning across the breweries table. You're doing the same thing here, but each tuple that you look at, you're not actually counting the tuple, you're counting the occurrence of this number. So every time you see a tuple, you say, oh, there's one more. Then look at another tuple. Oh, there's one more one. Look at another tuple. Oh, there's another one. You know, so that's a silly way to do it. Don't do it like that. Do it like this. That makes more sense. I mean, you could also, since you know that ID is a primary key, you could count the number of distinct keys. Whoa, from breweries. That would also make some sense. Whereas the one appearing though, it's not, it's being counted. So you count 223 ones is basically what that's doing. Why not just up arrow and change inside the brackets? Yeah, hey, good point. Why didn't I? All right, I will. Ooh, that was a bit extreme. Used the wrong arrow. Count. I think there's. No, damn. Oh, what's it called? Located in. Yeah. All right, beautiful. $223. Here's something interesting, which will sit with those counts that we saw before. If I count the number of distinct locations that are mentioned in breweries, that should be less than 223 because we know some breweries are located in the same place. So there's not going to be as many unique locations as there are breweries. And we get 195, which I think is, yeah, exactly. So that explanation about the counting ones, correct. If I wanted to count ones inside a tuple, I'd have to look for them. And what else? Where's something that might be, oh, one. There's something that might be a one. So founded is a U value. So count. Yeah, you're right. How right you are. Why aren't I using up arrows? Because I'm an idiot. Where did you count located in? I wanted to do count ID. Yeah, they'll do from breweries where. So you need to actually look for one in the tuples. And what am I going to get here? Big fat 0 because there are no breweries that were founded in the year 1. Right, so it's perfectly possible to get a value of 0 or an empty table if you ask a query. Well, look at that use. So no rows. There are no breweries that were founded in the year 1. But if I jump to 1996, probably a couple. No, quite a few. All founded in 1996. And if you don't want all that extra crap, you can say, only show me certain values. And probably in this case, you only want the names. There's no point printing out the founded year because you know it's 1996 because that was what you asked. All right. Yeah. So that's your database. Have fun with it. Yes, I have drunk all those beers. Over a long period of time, of course, you understand. Not in the last 6 months. Yeah. Yeah, well, if it was in just one afternoon, I probably wouldn't be alive. All right, so assignment 1, here's the SQL schema corresponding to that ER diagram. And you may notice the subclass mapping has just been collapsed into a single table because all of these subclasses have the same attributes. They're disjoint. Well, sure, that's fine. So they all end up here. So we may as well just put all the names. Oh, we need to have a type as well so we can distinguish. That's right. So can you just, you can just, when you copy the SQL dump file, do we do this in VLab first? Yeah. So my suggestion is that you have 2 terminal windows. One, you, right, so I've got 1 terminal. Well, you can get away. If you know how to use VI, 1 terminal window is sufficient. Hardly. I had not been drinking when I broke my arm. It was a sheer silly accident. You can get it, yeah, if you know how to use VI, you can probably get away with 1 terminal window. But what I do, I'd have 1 terminal window to edit stuff and another terminal window where I SSH to the d.csv server, and that's where I do all my database work. And so if I write a query in the window where I'm editing, I can then come over to the query to the VXDB window, and I can load that query up and then run it. Yeah, good luck. Crashing the servers. Yeah, so that's my suggestion. 2 terminal windows, one where you do your editing and the other window where you do your Postgres work. The editing window can be anything, any machine. The one where you're doing your Postgres work has to be on d.csv. What DW151? Yeah, so when you're on d.csv, you can see exactly the same directories, well, your own directories, as you can see in any other terminal window. No, beer would clag up the cooling system. Everyone get on 6 p.m. sharp. What? Run while through here. Right. go for your life. Yeah, sure. Yeah, so in both those terminal windows, you can be in exactly the same directory, but on different machines. So your regular machine for doing editing and your database machine for executing the stuff that you type in the regular window. So that's how I tend to work on databases if I don't just use a single window. All right, so that's a rough guide to the schema. What have I done here? I've bolded all the primary keys and I've italicized all the foreign keys, and I probably should have done bold italics here because the combination of those two things is the primary key for the brood by table. And the reason we make the combination a primary key is that you don't want to say VB was brewed by Carlton twice. So as soon as you've said it once, that's a unique entry in the brood by table and you don't need to repeat yourself. So you make the combination of those two primary keys. Where does it mention they are primary keys? No, probably down in alter table. If you have a look at the schema in the assignment spec, well, let me see, database schema. If you go down to the SQL and you go to brood by, here you go. So it's probably too small. Can I make it bigger? Yes, I can. All right, so the brood by table has beer, foreign key referencing the beers table, brewery, foreign key referencing the breweries table, and the combination of these two is a primary key. That's typical of end-to-end relationships. So, you know, you've got foreign keys going off to the entities involved in the relationship, and the combination of those two foreign keys is the key for the whole brood by relationship. And you can always have other attributes as well. If you, I don't know, if you wanted to put the time of day that they started brewing or something like that, you can add, you could add an extra attribute here. The shirt tracker assignment. You'd be struggling to track all these shirts. Oh, it is getting dark. Hang on a moment. What did that do? Oh, yes, that made it a little bit better. I suppose I could have just turned on the key lights as well. All right, let's get back to this. So anyway, you can look at that, have a look at the database, start playing around with it. All right, and this, I wanted to point out, the most useful way to implement this is through a single table mapping. Is this what? Has the room gotten darker and darker? Yes, as you descend into the depth of the assignment. No, it's because it's getting dark outside and I was using, yes, correct. I was using the outside light to light the room. So I just turned on the light in the room. Duh. All right, so the ingredient table, and we can actually go back to the schema. We do a single table mapping of these subclasses. Where is ingredients? And the order of defining these tables is also important because located in references location, therefore location has to be defined earlier in the SQL file. But getting back to ingredients, so we've got ingredient type and we've got the name of the ingredient. So this will say it's a hop and it's the Galaxy hop or something like that.
Sorry, Jazz. I'm just going to ask you one question because I think my question wasn't answered before and I need the answer. So this dump file that we're dumping into, like through that thingy, okay, yeah. That is basically the schema, isn't it?
It contains the schema, yes.
Yeah. That's why I was a little bit confused because I didn't see the primary keys in sorry,
Oh, yeah.
mine is
Oh,
because it was
okay.
defined later on, because you can't upload the data the way it is. So you have to alter the table, isn't it?
Yeah.
Okay.
Yeah.
All right. I think there was another way of doing this in question 10, but I haven't got around to doing it because I was still kind of like, I did up to 8, couldn't get 9 done.
Yeah, yeah, sure.
So I just thought, I know you showed us how to do it using auto tables. I thought just do the auto table, like you've got the dump there, so upload that thing. The scheme that you showed us is this is how it's represented, but
Yeah.
you're gonna have a problem putting your data because of all these prime and foreign keys going everywhere, right? Is that
Yeah,
right?
yeah.
Okay. Yep.
That's right.
Thank you.
Okay. All right. Wow, that was a bit scary. Someone talking at me in the lecture. Fine. Yeah, so we just did that as a single table. It's a little bit contrived to even, you know, write it like this, but I just wanted you to see. Did I? I don't look like a startled moose. Right. So next thing to look at is how do we change databases? Well, we've obviously seen you can load from a dump. How do we create a dump? And don't start laughing at that. Here's how we create a dump. There's a PG dump command. You've got an existing database. And what that will do is produce a file like the one we looked at. In fact, there's the raise hand button. Where does that even appear? Oh, I see. Oh, yeah, it appears like that. Wow. Have you got a question? No. Good. Yeah, I can't see any of you because I've got the chat window over the top, which saves a bit of space on my screen. Yes, Zach. No, no, now we're just going to get people randomly raising their hand for no reason. All right. So creating a database, create DB. All these commands here are things that work at the command line level. So they're shell commands, if you like. Oh yeah, the other thing I was going to say about PG dump, you can actually get PG dump to dump the database in regular SQL format. So it doesn't, I don't think it does those alter tables at the end. It creates the tables in the correct order and loads them up using insert statements. I may be wrong, but if you want to find out how to use it, hey, that will usually help you. Well, there's a lot of things you can do. Blah, 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 blah. Where is it? Oh, somewhere it says, wow, look at all these options you've got. Beautiful. You can exclude the table data if you don't want to get the data. You can dump schema only. Oh, I was sure somewhere. Too many options, all right, you can have a look through them, but you can get it to dump in regular SQL, which would be useful if you want to load into a different database, although why would you? You've got Postgres. All right, so creating a database overall, once we've got a database, we've got to get data in there, insert into, table name, keyword values, and then in parentheses, a list of values that are relevant to that table. They have to be in the order that they were defined in the create table statement. If you want to only insert some of the values, then you can put a list of attributes in here and then just give values for those attributes. All the other attributes will get a null value. And if you've got those attributes defined as not null, that's a problem and your insert will fail. And I should have put semicolons at the end of all of these lines because you always terminate an SQL command by semicolon. So those things like \d and so on are not SQL commands, they're PSQL specials. All right, delete from a table, specifying a condition. If you don't give a condition, it just deletes all the tuples in the table. A mistake I have made once and will never make again. To restore from a dump. So always put a where condition when you're doing deletions. Updating a table. So here what you're doing is you're modifying the value of a particular attribute or field. And you need to say for which tuples do I want to make this change. And often you'd identify an individual tuple by giving an ID. Once again, don't leave out the where condition. I have also made that mistake, and you don't want to do that. All right, create a table, or we've already seen plenty of examples of that. You give attributes and constraints. Delete from table without a condition takes all of the tuples out of the table, but leaves the table itself. If you totally want to get rid of the table, drop table will do that. And Postgres has got a special copy command, which is used extensively in the dumps. If you go and have a look at the s1.dump, you will see that. Querying a database. All right. Oh, what a shame. It's 6 o'clock, so I can't get into it. Actually, this is probably a reasonable place to stop, and we can talk all about SQL on Thursday. And you can, if you want to find out all about it now, go and have a look at the videos. But the standard SQL that you're probably all familiar, well, some of you may be familiar with, is just that. Select comma separated list of attributes, technically comma separated list of expressions from a particular table, and only getting tuples that satisfy a certain condition. But there's a lot more to SQL than that, and I'll be talking about all of these different things on Thursday. All right, time to stop the recording. Recording has stopped.